Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a multiple choice question on electric power dissipated by induced current in a closed coil with a shortcut method. The question is as follows. A short-circuited coil of many turns is placed in a transverse time-varying magnetic field B. The electric power dissipated due to the current induced in it is P1. Now, the number of turns of the coil is quadrupled by stretching it uniformly such that the radius of cross-section of the wire is halved and the power dissipated by this coil is P2. Then, the ratio P1 by P2 is. The options are 2, 1, 1 by 2 and 1 by 4. Before proceeding to solve the problem, let us recall the related concepts. First, let us understand the figure in the question. The coil in the figure looks like a solenoid. This is deliberately done to indicate the number of turns of the coil and the thickness of the wire. When a potential difference of V volts is applied across a wire of resistance R, a current I flows through it. From Ohm's law, we have V is equal to IR and power dissipated is P is equal to VI, which is equal to V square by R. Resistance of a wire of length L and area of cross section A is given by R is equal to rho L by A, where rho is the resistivity of the material of the wire. If R be the radius of cross section of the wire, then A is equal to pi R square. Therefore, R is equal to rho L divided by pi R square. Therefore, we have R varies as L divided by R square. Whenever magnetic flux linked with a coil changes, an EMF is induced in it, which is directly proportional to the number of turns of the coil. Therefore, we write V varies as N. When a wire is stretched uniformly, there will be deformation without change in volume. Therefore, pi R square L is equal to constant, which gives L varies as 1 by R square. Now, we are in a position to solve the problem in the question using these concepts. It is given in the question that the number of turns of the coil changes from N to 4N. Therefore, N1 by N2 is equal to 1 by 4. Length of the wire changes from L to 4L. Therefore, L1 by L2 is equal to 1 by 4. And radius of cross section of the wire changes from R to R by 2. Therefore, R1 by R2 is equal to 2. Therefore, equation 1 gives P1 by P2 is equal to V1 by V2 whole square into R2 by R1, which is equal to N1 by N2 whole square into R2 by R1. From equation 2 we have R2 by R1 is equal to L2 by L1 into R1 by R2 whole square. Therefore, P1 by P2 is equal to N1 by N2 whole square into L2 by L1 into R1 by R2 whole square. Again, equation 4 implies L2 by L1 is equal to R1 by R2 whole square, which gives P1 by P2 is equal to N1 by N2 whole square into R1 by R2 whole to the power 4, which is equal to 1. Therefore, the correct option is B. Now, we will discuss a shortcut method from understanding the concepts. When the number of turns N changes to Kn, the induced EMF V changes to Kv. This happens when the length of the wire L changes to KL. Due to this, area of cross section of the wire A changes to A by K, since the volume of the material of the wire is constant. Now, R is equal to rho L by A. Therefore, R changes to K square R. Now, P1 is equal to V square by R, which changes to P2 is equal to Kv whole square divided by K square R, which is equal to P1. Therefore, P1 by P2 is equal to 1. Hence, the correct option is B. This completes the answer to the question.